briefly, the point here is regulatory science and the irreproducibility crisis. In effect, I'm saying the government is central to the problem and the solution. There's the statistics, $136 billion a year for science funding, biggest single source. Also, all of the federal grant rules, in effect, govern how you, do your immense amount of your science. Even if you're not doing it directly, you're doing it with the hopes of getting a grant. Funding bias by grant panelists. They like exciting research. That has a really big effect also. So you got to fix both how the government funds science and how the government uses science. And it's not just the politically exciting stuff like climate science, et cetera. Hydrogen storage materials, energy system modeling, oil production modeling, and agronomy. And I'm not even going to bother with the slides because that would just take too long. Everything you haven't heard of that the government's involved in, the reproducibility crisis matters there too. So it matters for everything. So massive reforms needed. And in effect, I am saying so we're going to start with what's controversial. In effect, I'm saying the government needs to require stuff. So, and in effect, a lot of people are saying scientists should do things, and I'm saying you got to make them do it. So that's the big ask. All right, so what do you do? First, least controversially, I like to think, adopt current best practices. I think the NIH, people have been mentioning it, it's a good example of best practices. I will look at the EPA and say, you ought to adopt the NIH's best practices in terms of requiring reproducibility, and in fact, across the government. So there's already real reform in the government. Don't ignore that. Build on it. Go farther. Require stuff which is being done voluntarily. The Center for Open Science, they do pre-registered research protocols. Make that required of every government that gets funded, everything that's funded, everything that informs government. And ditto, require publicly accessible data files, algorithms, statistical softwares. Shout out to ontology, rigorously standardized descriptions of materials and research procedures, and require anonymized research data on human steps. I do think EPA strengthening transparency in regulatory science, I do think that's a good first step. Moving on. Change procedures, make it more difficult to accept irreproducible research. And the shout out to Tony Cox. Falsifiable theories of causal determinations. Stan Young, integrate statistical procedures to assess whether a body of scientific literature exhibits the characteristics of publication bias or p-hacking. Perhaps use a standard reproducibility number, an R factor, to quantify how often a piece of scientific research has been reproduced. That's something that Yuri Lezebnik has been working on. Rather nifty, I thought. Try to inhibit groupthink. And this is something where groupthink's human nature. The urge to fund exciting research is human nature. It's difficult. There's a variety of things you can do. Limit the ability of grant recipients to serve as grant panelists, require panels to include members from a bunch of different institutions, include private industry, cap the grant money available for any one research or institution. These are suggestions. Human nature, I think most practical solution, dedicate a large portion of each grant's funding agency's funding to replication studies. Bigger switch, make expertise reproducible. And this is, again, related to Tony Cox's point. And when I say this, big theoretical thing, not invented by me, distinction between regulatory science and research science. Research science aims to discover truth, aims to discover knowledge, increase knowledge. Regulatory science aims to provide answers to policymakers' questions, articulated according to specific legal standards and completed within a set amount of time. It determines policy. It determines do you regulate. It determines how do you regulate. They have different evidentiary standards. In effect, regulatory science is lower. Unpeer-reviewed, gray literature, technical reports, conference proceedings, etc. This is either good if you think we madly have to act now to regulate, or you think this is really bad if you think we should not be in an all-fired rush. Either way, standards for regulatory science and research science, they're different, and you need to think about them differently. And the crucial thing here is it's government experts who determine the standards for whether and how to enact regulations. Government agencies delegate substantial powers to the experts, and that's, define the relevant field of scientific literature, define the standards for research that informs government policy, determine what procedures will assess the quality of scientific research. And this is articulated by the weight of evidence standard. So what I'm saying is, regulatory experts, they're as fallible as any research scientist. You need to demand regulatory reproducibility from experts, which allows, severe tests to their discretionary exercise of expertise. The decisions experts make must be independently verifiable and reproducible. Way to do this: constraints on experts' discretionary powers. And a model which I think is, in point of fact, relevant. Researcher degrees of freedom can produce spurious research results. Expert degrees of freedom can produce unfounded policy. A researcher decides, what comparisons to make. That limits the number of possible research conclusions. Expert decides which policy alternatives to consider. That limits the number of possible regulatory policies. So government agencies need to constrain experts' discretionary powers. What does this include? Inclusion and or exclusion criteria for scientific literature, stated, rigorously standardized terminology with clear operational definitions, requirements to provide coherent, fully articulated accounts of the logic leading from research data to policy conclusions, requirements to give less weight or none at all to research that is not publicly accessible or reproduced. You have to account explicitly for study quality criteria, publication bias, unverified modeling assumptions, falsifiable theories of causal determination. Experts must be constrained in their use of the weight of evidence standards. And I'm going to adding to this, statistical significance is under attack. For good or bad, it may be going. And this matters because statistical significance has been the master protocol for regulatory science. It's been the uniform rule that constrains experts when they award grants or assess scientific validity. So if statistical significance is going, some of you say it shouldn't, but if it does, that's going to get rid of a very powerful constraint on discretionary expertise. We need to constrain expert degrees of freedom as a substitute master protocol, and that's precisely because we may be about to lose statistical significance and its function as a master protocol. It's a trade-off. You lose valuable material to inform regulatory decisions, but it gives you another useful tool to allow you to appraise regulatory decisions rigorously and restrict the influx into government decision-making of science with no hard reproducibility requirements. So, trade-off, I think there's a substantial gain. So, that's the big ask. That's the strong, thing. And then I think there's a number of things you need to do to get buy-in. And that's buy-in, political, bipartisan, buy-in from research scientists. And worth doing because I really think we need reproducibility. I think we need broad-based support. So explicitly tailor reproducibility reforms for the different disciplines. Don't just say you want reproducibility that goes everywhere. Don't say, I want to reform statistical significance for genome-wide association studies. They have a p-value threshold of 5 × 10⁻⁸, which is incredibly powerful. It doesn't matter. When you're talking about the experimental sciences, talk about methods reproducibility. Talking about the observational sciences, talk about public data. Take account of the difficulties. It is hard to rigorously reproduce the Harvard Cities study, harder than a lab experiment. Acknowledge. 2, draft detailed plans, upgrade existing research used to support regulation, make sure that it meets stiffened reproducibility standards. Congress must spend lots of money as I tell them to do. Do that. Fund the research to anonymize existing research data on human subjects so that it can be submitted to public scrutiny. Direct funds to make sure that archives of climate data and modeling are brought up to modern reproducibility standards. Make the legal arrangements with private holders of data to publicize the data, no damage to confidentiality or proprietary interests. Fund new equivalents of the Harvard Six Cities studies using fully anonymized and publicly accessible data. Make sure that reproducibility reforms aren't held hostage over worries that they will eliminate the data available for government regulation. Then, focus reproducibility reforms on the standards for future regulations rather than initiatives to rescind existing ones. Aim for regulatory stability to maximize political support. I was really struck by this. The American Chemistry Council has this comment on strengthening transparency in regulatory science. We encourage EPA to avoid the creation of unnecessary ambiguity and burdens and refrain from the application of this proposal to previous records. They've already invested in regulatory compliance. They don't want to lose their investment. Get them on board. Higher reproducibility standards will suggest that some current regulations should be narrowed or indeed rescinded. Have this occurred through, say, measured updates of the regulatory codes over a 10-year period. Make regulatory reform aim at regulatory stability so as to gain broad support from the American public. So, quick conclusion. Reproducibility reform of regulatory science should require research transparency, revised procedures to inhibit and detect the production of irreproducible science, and transparent constraints on discretionary expertise. And then you maximize your chance of success if you tailor reproducibility reforms for the different disciplines, draft detailed plans to upgrade existing research so that it meets stiffened reproducibility standards, focus reproducibility standard reforms on the standards for future regulations. Make sure that you're improving regulatory science, not disabling it. Place high barriers to regulation, not insuperable ones. And realize that humans will game any system. They're gaming this one. They're gaming the one I'll propose. I'm hoping that if something like this were to come about, it would be the useful foundation for future rounds of regulatory reforms. That was only 30 seconds, right?